All right, welcome to work, guys. I hope you're all comfortable, sitting in your pajamas at your desk right now, ready to do some equations. Just going to go over some of the simple series circuit stuff. Stuff's going to build up and get harder real fast, so it might be a little slow starting off for some of you guys that already know it, but I want to make sure we don't lose anybody along the way. So we're going to start off with a couple real simple resistor series circuits. Right here we got a 3 resistor series circuit, and they give us our voltage total on a DC source. So we're just going to work our way through it. Now, I've been putting these boxes everywhere for you guys just because it's the simplest way for me to kind of itemize all the information without it getting too messy. So I just plug in all the values. And when we see that we have any 2 values in one category, we know we can solve for any missing values in those categories just using basic Ohm's law. So we're going to go ahead and just input the values that we already have on this circuit. And we know that 125 volts is the total voltage in this circuit. So we're just going to go ahead and put that in the box here. Now I'm going to call these resistors R1, R2, and R3 just so we can keep them separate. Get their values put in too. So we got 20 ohms for R1. 30 ohms for R2. And 50 ohms for R3. Now, based on this information, all we really need to do is get one category where we have 2 slots filled in or more, and we can use Ohm's law there. So knowing that they're in series circuits, the resistive values are additive, we can take all these and simply add them together and find out the total. So let's go ahead and do that. So 20 plus 30 plus 50, simple math, that gives us 100 ohms. Now we've got our 2 values in that category, so it should be easy to solve. So based on Ohm's law, we got 125 volts, and we're going to divide that by 100 ohms, which gives us 1.25 amps. Didn't even need a calculator. All we did was divide, move that decimal over 2 places. All right, the next rule we know about series circuits makes it easy because the current we know in a series circuit is consistent across each resistor all the way back to the source. So if we got 1.25 amps here, each of these resistors is going to get that same current across it. So we know we can have the easiest values to fill in right here now because we got 1.25 amps across every single one of these. No work necessary. Just add those values in the missing slots. Couldn't get any easier than this. Now that we have these values, we have more than 2. We have at least 2 values in every category. We can solve for any missing ones. So all we have to do is use Ohm's law. We know that the current multiplied by the resistance is going to give us our voltage. So grab your calculators, make it easier on yourselves, and just go ahead and plug in those values. So 1.25 amps for resistor 1 times 20 ohms, 25 volts. 1.25 amps times 30 ohms gives us 37.5 volts. And 1.25 amps times 50 ohms gives us 62.5 volts. Now we got a voltage drop across every resistor, but in the end all those voltage drops should add up to our total. So an easy way to check our work on this, make sure we got the right answer, is we can just add all these values together and see what we get. If we don't get 125, then we know we made a mistake along the way. Now this is only going to work for series circuits, so don't assume that when we get into the more complicated stuff it's as easy as this. But when we know something's in series, we can add it up and check our work here. So if we take 25 plus 37.5 plus 62.5, that gives you 125 volts. All right. So that filled in all the missing values. We were able to find the voltage, current, and resistance at every single resistor. In our handy little chart right here, all that information is filled in. So keep an eye out. We'll be sending some more videos out to help you guys out. And let me know if you have any questions.